Hey guys, welcome. Section 9.1 Part 2 video. So the theme here was to cancel items, cross-cancel items, and then multiply and see what's left. But given a problem that has a whole bunch of pluses and minuses all over it, like these two do, 7 and 8, that should be the giveaway. The light bulb should go on and tell you that we're supposed to do some factoring here. And again, when in doubt, factor it out, right? So you're always supposed to do that anyway. Well, first thing I'm checking for is GCFs. I don't see any GCFs in problem number 7. I don't have GCFs, but I do have a b squared. That should tell me I'm going with the two parentheses. B squared, b and b. 28, likely to be 7 and 4. If I want to get that plus 3 in the middle, positive 7, negative 4, that would get me that negative 28. So I like doing this. You don't have to. I don't want to get caught up in accidentally using that again because I have changed it and factored it. So I like crossing those off. I wouldn't cross them off so much that you can't see them anymore. That way you could always go back and double check. Upper right corner. B and B. 49, got to be 7 and negative 7. So again, I'm going to just put a light line through that guy so I don't accidentally use him again. Well, here's the point. I want to cross cancel. I can cross cancel matching binomials. B plus 7, B plus 7, matching. The B minus 4, the B minus 7, not matching. Can't cancel them. Now, the 4B and the 16, however, those aren't binomials, they're monomials. And if they're monomials, you get to cancel them no matter what. Now, the upper left has a B, bottom right does not. So I'm kind of stuck with that B. So be a little bit careful. I can cross off the 4 and I can say 4 goes into 4 once, 4 goes into 16 4 times. But if you notice what I'm saying, it'd be really easy to lose track of the fact that that little B up there in that left corner is still there. So that's why maybe it's not a terrible idea to put circles around things that are still left over. So I could put a circle around this 4. Hey, he's still there. I'm not going to bother putting circles around the B minus 7 and the B minus 4 because it's pretty obvious that they're still left over. All right, once the cross canceling is done, now we get a times. So if I'm going to multiply across, I get a 1 times a B minus 7. So I'm going to do distributive property here. I'm going to take that B times both those guys, and I got B squared minus 7B. And on the bottom, I have that 4 left, and I have the B minus 4, and I'm going to distribute those guys. I got 4B minus 16. Done. Again, don't think about canceling binomials unless they're literally matching. Back up to the problem. We had a B plus 7 that was exactly the same as another B plus 7. So the stuff that I have left does not match. I cannot cancel, and I'm done. Okay, number 8 looks a little tougher, and that's because it is. I'm actually going to take the time to rewrite this one because there's a lot going on. So first thing I notice is upper left corner has a GCF of 3. Let's do it. Here's what's left. The bottom of that guy, he has a D squared. He has D squared. It's probably the 2 parenthesis thing. D and D, nothing but plus signs in the problem. If I go with 8 times 3 is 24, that is going to get me that 11D that's in the middle times. This guy has a GCF as well. Hopefully you notice that. GCF of 4. Would leave this. In the bottom right corner, finally, this one does not factor. No GCF, no y squared. Nothing I can do with that. All right, well, the point is to get something to cancel. Do you see matching binomials? Well, what do you think? D plus 3, 3 plus D, are they the same? They're flip-flop, but if you think about it, positive D, positive 3, positive D, positive 3. They match. Cross them off. But here's where it gets a little bit weird. It would be really tempting to cross off that 3 minus y and y minus 3, but I would ask you this. What's the sign in front of the y up here on top? It's negative. What's the sign understood to be in front of that y? Positive. They don't match. They're not exactly the same. But how about this trick? What would happen if I would have made that GCF a negative 3 instead? That would have switched the signs of those guys inside, and now they match. So I've got a negative 3 and a positive y. I've got a negative 3 and a positive y. they are exactly the same, and I can cross them off. So search around. Do you see anything else that we can cancel? Left with a -3, left with a 4, left with that d plus 8. He's a little more obvious. But I do have to multiply at some point. So if I multiply the top, and all I have left on the bottom is that d plus 8, that'll do it. One more time. I apologize if I am saying this too many times, but you cannot cancel unless it's a matching binomial with a matching binomial. The -12 is not a binomial. The d plus 8 is. So therefore, I'm done. I cannot cancel that 12 and that 8. And again, my advice is if you're not sure about canceling, don't do it. All right, I'm going to squeeze in a couple division problems here before this video is over. We're going to have a part 3 here, but it's okay. All right, flashback again to 3rd grade, 4th grade, whenever that was. Do you recall this? When dividing fractions, you're supposed to flip the second fraction, then change it to multiply. So bad news is you got to remember to flip the second fraction. The good news is if we change it to multiply, it will be the exact same thing that we were just now doing. So let's drop down here and try these guys. Number 9. Notice, number 9 does not have any pluses or minuses involved anywhere in that problem. So I am not going to be doing any factoring. But I do always have to do exponents first. So I'm going to take care of this guy. All right, everything gets squared. Well, if the 6 is getting squared, it would be 36. If the m is getting squared, he'd be n squared. And what are we supposed to do with the exponents in this case? Times them. All right, so my exponent's done. Now I can pull out the division rule. So one more time, the division rule is to change it to multiply and flip the second fraction. And if I'm changing it to multiply, then I'm going back and doing exactly what I just did on the previous problems. So let's find something to cross cancel. 12 goes into 12 once, 12 goes into 36 3 times. I see 3 n's and 8 n's. And if I subtract them, it will leave 5 n's. Now, where are the m squareds at? Cross cancel? No. They're both on the bottom. So something's got to be able to cancel. One's got to be on top, one's got to be on the bottom. Hey, let's circle what's left. I see a 1. I see that guy. I see that guy. I see that guy. I see that guy. So there's all the things that are not crossed off. So now I multiply across. 1 times n to the 5th on the top is n to the 5th. On the bottom, I've got a 3, obviously. It wouldn't make sense to leave it an m squared and m squared when the rule is to add the exponents when multiplying. All right, let me see if I can squeeze this number 10 in. So no factoring, even though it's w minus 7. There's nothing I can do to that. What is a division problem? That's a subtract sign, which means I got to flip-flop it. So z to the 4th goes up top. 7 minus w goes to the bottom. All right, do those guys match, this w minus 7 and the 7 minus w? They do not. Well, okay, we just got done saying if you were to take a set of parentheses and put a negative sign out in front or a -1, that would switch it around. If you multiply the bottom by something, shouldn't you multiply the top by that as well? So let me rewrite what we got. We got the w minus 7. We get the z to the 7th times. Okay, now I have changed that guy into a negative z to the 4th. So what would happen here if I distributed that out? Well, the w would become positive. And since the 7 was positive to start with, he would become negative. So do you see what that -1 trick does? He makes those w minus 7s match up. Matching binomials, cross them off. 7 z's, 4 z's, leaves 3 z's. But you got to be careful. That negative is left. And there's nothing left on top, guys, but there is no such thing as writing a fraction with nothing on top. So I hope it would occur to you that that's a 1 that's left. And what's not crossed off on the bottom? Z to the 3rd. And there we go. Final answer for that guy. All right, a couple more division problems left in part 3 video, and those do involve factoring. So if I were you, I would check them out. Thanks for watching, as always.